Hello again, dear students. We're still reviewing the prerequisites necessary for starting our course for this year, Algebra 1. As usual, we start by a warm-up. Pause pause the video and give yourself 30 seconds. Try to answer the following question and then come and check back your answer. It is required to evaluate each expression given that A is equal to 4, B is 6, and C is 2. The given expression is 3A plus B squared times C. Now, let's replace A by 4, B squared, which is replaced by 6 squared, times C, which is can be substituted by 2 because the value of C is 2. Now I did the first step, which is replacing each variable by its value. I just did the substitution part. Now I'm using the order of operation. I have multiplication exponents. 3 times 4 is 12 plus 6 squared, the 36 times 2. So I did the exponent first, and then I had here 3 times 4, it's 12. Now I have in the same problem addition and multiplication. According to PEMDAS, I will start by the multiplication. 36 times 2 is 72 plus the 12, so it will be 84, which is the answer is B. Hopefully you did it correct. Let's see the next one and give yourself 30 seconds to answer it. Again, we're reviewing what we had in the previous tutorials. We scanned simplifying expressions using order of operations as in the first example, and we also reviewed simplifying expressions using distributive property. We have here 2 times t plus 5r. So before doing anything, you must know for sure you're going to use distributive property to multiply this 2 by each term between the brackets here. So the 3r will remain as it is. And when you multiply 2 times t, it is 2t. And 2 times 5r, it is 10r. According to the like terms which we have here, like terms means same variables raised to the same exponent. I have here 3r and 10r, as if I have 3 bananas and 10 bananas. And the t is a different variable. It's unlike term, you can never add them. So to simplify this expression now, I will add the bananas all together. 3r and 10r will be 13r. It can never be added to 2t. 2t is a different or unlike term. And that's it. It is totally simplified. It cannot be simplified any further. It means the answer is J. Now our new topic, which we are reviewing today, relations and functions. And as we said earlier, all those concepts are introduced earlier in previous years, but those are essential to start our course for this year. What are the objectives? The objectives of today's lesson is to identify different representations of relations. We're going to see how to represent relations. Determine whether a relation is a function. We're going to identify the meaning or the condition which makes a relation is a function. And we're going to evaluate a function. Let's recall the meaning of relations or how to express relations. As we studied earlier, relations can be expressed or represented as ordered pairs, like this relation. This is a relation. We use the 2 curly brackets, and in between we have the ordered pairs. 2, -6, this is an ordered pair. 1, 4, 2, 4, 0, 0, 1, -6, 3, 0. As a whole, as it is, all in all, it is called a relation. And it contains between the two curly brackets ordered pairs. Each ordered pair has an x value or an x coordinate and a y coordinate. All the x's are called the domain, while all the y's are called the range. Again, a relation can be represented one way of representation to represent a relation using this notation, using the two, which is called ordered pairs, using two curly brackets, and in the middle we have the ordered pairs. And as we said earlier, ordered pairs, each ordered pair has an x coordinate and a y coordinate. All the x values are the domain, while the range is all y values. So in this particular example, if he's asking me to find the domain and range for this relation, all those x's, 2, 1, 3 are, and the 0 are representing the domain. Why didn't I repeat the 2 and 1? This is really important in using set notation. We never repeat the same element. So if I have the same x value or y value, if I have the same value or element of the domain repeated, we write it only once. So again, all those x values are representing the domain, but if we have a repeated value, we never write it twice, we only write it once. So I have 2, 1, and I have another 2, 1. I wrote only 2, 1, and I have the 0 and 3. Do they have to be written in order, like in descending order, decreasing or increasing order? It's okay, it doesn't matter, they don't affect your answer, but it's better to be written in descending order like this. So 0, 1, 2, 3, those are the values of the domain or the elements of the domain. What about the range? I'm using a different color now. The -6, 4, and I have another 4. As we said earlier, we're writing it only once. We have 0 and -6 again, so we're not repeating it, and we have another 0. So I'm only writing -6, 4, 0. Those are the values or the elements of the range. Is it the only way to express or to represent a relation? No, we have a different representation or another representation, which is using a table of values. Again, we have two columns. It can be a horizontal or a vertical column. Sometimes you might see the table like this. And here are the values of x, and here are the values of the y. So it doesn't matter whether it's vertically or horizontally. We use a table to represent a relation, the x values, which are the domain in one column, and in the other one we write the range, which are the y values. So here 3, 4, it comes here 3 and 4. 7, 2, it's written here. 0, -1, -2, 2, -5, 0, and the last ordered pair 3 and 3. This is the second kind of representation of a relation. Another way to represent, or another representation of a relation, is called mapping. And in mapping, we use two geometrical figures, either two ovals like here, or you might use two rectangles. And we use arrowheads to pair each x value with its corresponding y value. So here are all the x values, the domain, in one rectangular shape or one oval shape, any geometrical shape. In the other shape, we have the range, which are the y values, and then we use the arrowheads. We listed here all the x values, 2, 1, 0, and 3, again without repetition. We don't repeat the same x value. If it's repeated, we write it only once, as in the ordered pairs, as in the domain and range. And we wrote here all the y values. Let me use another color. We have -6, 4, and 4 is written twice, though that's why it's written only one. And we have 0, -6 again, and 0 again. And we're using arrowheads to pair each element from the domain with its corresponding element in the range. If I have 2 and negative 6, I have an arrowhead going out from 2 to negative 6. It means 2 corresponds with negative 6. This is to express the first order pair 2 and negative 6. Let's see the next one, 1 and 4. So another arrowhead coming from 1 moving to 4 because 1 is corresponding with 4. Again, 2 and 4. 2 corresponds also with 4. So I have another arrowhead coming out from 2 to pairing the 2 with 4. 0 with 0, 1 and negative 6 again. So the 1 pairs once with 4 and once with negative 6, 3 and 0. This is called the mapping representation or the mapping method to represent a relation. To sum it all up, those are the 4 different representations of relation. The ordered pair, using the curly brackets. In the middle, we have the ordered pairs xy, xy. We have the mapping method, either to have 2 ovals or 2 rectangles, the x in one of them and the y values in the other one. Tables, we can represent relations using tables, also 2 columns, whether they are vertically or horizontally. The first column represents the x values, the domain, and the other column represents the y values, which are the range. And the last kind of representation of relations using graphs, graphing or plotting the points on the coordinate plane, using the x-axis and the y-axis, of course. Let's see the first example here. Express 4, 3, negative 2, negative 1, 2, negative 4, 0, negative 4 as a table, a graph, and a mapping. So it's given a relation in form of ordered pairs, and it's required to be represented in 3 different forms, in the table representation, graphing, and using mapping. As we said earlier, the table, you just construct any table of values, whether horizontally or vertically, 2 columns, 1 for x and 1 for y. 4, 3, here we go. Here are the 4 and 3. Negative 2, negative 1, negative 2, negative 1. 2, negative 4, here are the ordered pair here. And then the last one, 0, negative 4. This is the first method or the first representation of this relation. We listed all the x values in one column and all the y values in the other column. And here are how to graph it. 4, 3, here is the 4. This is the x. And then we go 3 up over the y. So this is the first point for 3. And then we have negative 2, negative 1. Here is negative 2, negative 1. And then we have 2, negative 4, the third point. And the last one here is 0, negative 4. Another way to represent a relation using graphing, on the coordinate plane. List the x values in the domain and the y values in the range. Draw an arrowhead from the x values. The last method is the mapping method. It is the same relation here. We're mapping it. This is how we use mapping to express the relation. We put all the domain values, the x values, in one shape. As we said earlier, either it's an oval or a rectangular shape. And the range values, the y values in the other one. And we're pairing each x value with its corresponding y value using arrowheads. Okay, draw an arrow from the x value to the corresponding y value. So 4 and 3, that's why we have an arrowhead from 4 to 3. It means we have 4 and 3. Negative 2, negative 1, an arrow from negative 2 to negative 1. 2 and 4, negative 4, an arrow from 2 to negative 4, and then the last ordered pair, 0 and negative 4. Those are the 3 representations of the same relation given in example 1. The second part of example 1, determine the domain and range for the relation. As we said, the domain, which are the x values. To express the domain, we also use the curly brackets, and we list all the x values of the relation. 4, negative 2, 2, 0. And again, I'm reminding you, if we have a repetition, we don't repeat the same element twice in writing the domain or the range. If we have a repeated x value or a repeated y value, we only write it once in the domain and the range. Now, let's write the range, which are the y values. I'm using another color to make it easier for you. The 3, -1, -4, and we have another -4. That's why I'm writing it only once. So the domain, which are all the x values, 4, -2, 2, 0, while the range, which are all the y values in this relation, 3, -1, -4. -4 is repeated twice. That's why in writing the range, I wrote it only once. I don't repeat the same element, whether it's in the range or in the domain. Now, give yourself 20 seconds. Try to figure out the answer of this one. Express the relation as a mapping. First of all, he's asking for a mapping method. So this means I'm excluding the first two, A and B. This one using tables, this one using graphs, I'm excluding them. I have two other answers, C and D, and both of them are mapping. I just have to find out which one is the correct mapping or the correct pairing of each ordered pair. 3, -2, this is 3, -2, 4, 6, this is 4, 6, 5 and 2, -1, 3, so this is the correct answer. Now, the next part of this topic is a function. What makes a function different than a relation? First of all, you have to know for sure that a function is one kind of a relation. A function is originally a relation under certain condition. And what is this condition? That the x values cannot be repeated ever. Let's see this question here. Do the ordered pairs represent a function? I have a relation here, and he's asking me whether it represents a function or not. What do I have to do to figure it out? I have to go to the definition of a function. In order for a relation to be a function, each value of x should not be repeated. Each value of x should be pairing or corresponding with exactly one value in the y in the range. So to determine here, I'm looking at the x values. I have 3, 7, 0, -2, -5, and I have another 3. Since I have the same x value pairing with different values of y, 3 here, once corresponds with 4 and once corresponds with 3. Since I have the same x value repeated, I can say, no, it's not a function. And if he's asking me to explain, I have to explain why, because each x value should pair only with exactly one value from the range, and here the 3 is repeated. Let's see the next one. 4, I'm looking to determine whether it's a function or not. I'm looking to the x values, 4, 5, 8, 9. No repetition in the x values, so yes, it is a function because there is no x coordinate or x value is repeated. How to identify a function using mapping? The easiest way is to look at the arrowheads. If you see two arrowheads coming out from the same x value, you directly say it's not a function. In this example here, since I have each x value has exactly one arrowhead coming out from it, it means it's pairing each x value with exactly one y value. So you can say it is a function. Again, in mapping, you look directly to the arrowheads. If you see two arrowheads coming out from the same x value, it means the x value is repeated. It means this is not a function. But in this case, in this particular example, it is a function because there is no repetition in the x values. Let's see this another example using tables of values. The domain here, -7, -4, 2, 5, no repetition, no x value repeated. So yes, it's a function, and to explain it, you have to say each value of the domain corresponds with exactly one value from the range, or simply you can say there is no repetition in the x coordinates. Now give yourself 20 seconds, pause the video, answer this question. What do we have here? We have a relation expressed or represented in a table, and it's required to determine whether it's a function or not, and you have to explain. We directly look at the x values. We have 3, 1, 2, and 3, so the 3 is repeated, which makes it not a function. So which one of those you're going to, I'm going to exclude the 2. Yes, I have 2 no's here. One of them, no, the element 3 in the domain is paired with both 2 and -1. It means there's a repetition. 3 once paired with 2, and 3 once paired or corresponds with -y in the range, which makes it not a function, and this is the correct reason. The last part, how to identify a function or to determine whether it's a function or not, using a graph. In the graph, in the coordinate plane, to determine whether it's a function or not, we have a simple test which is called a vertical line test. A vertical line test means for any graph you have, if you need to know whether it represents a function or just a relation, you draw a vertical line passes through this graph. If it crosses it in exactly one point only, you can say it is a function. If the vertical line crosses the graph in more than one point, it is not a function. Let's see those 4 examples here in the bottom of the page. I have a graph of a function. It's not linear, it's a non-linear function. Actually, this one function studied last year, it's called quadratic. To test it or to know, to determine whether it represents a function or not, we draw this orange vertical line. You can draw it anywhere. And as you can see, any vertical line would pass or would cross this graph in exactly one point only. So it means it is a function. For the next graph here, if you draw any vertical line anywhere, it would cross the graph in exactly one point, so again, it is also a function. The third graph here, if you graph any vertical line, as you can see, like this orange one, it would pass or cross the graph in 2 points, more than one, so that's why it is not a function. Exactly like this one also, when you graph a vertical line, it passes in more than one point, so it's also not a function. So this is how to determine or to identify a function graphically using a vertical line test. Let's see if we can do this. Pause the video, try to answer it on your own, and then come back and check your answer. Okay, we're back again. Let's see the first graph here. If you graph any vertical line anywhere, like here or here, anywhere, as you can see, this vertical line is passing or crossing the graph in exactly one point, so yes, it is a function. The next graph here, if you graph any vertical line anywhere, it will cross the graph in 2 points, so it's just a relation, it's not a function. For the third one, yes, it passes in exactly 1 point. The fourth graph, actually, it is a vertical line, so of course it's not a function. A function can never be vertical. It means all those x values are corresponding with different values of y, so any vertical line, of course, is not representing a function. For this fourth graph, if you graph a vertical line here or anywhere, you would see it passes or crossing the graph in more than 1 point, so it is not a function. The last one, it is a function. Please check the homework uploaded on the drive until we meet again. Thank you so much.